Hello, hello, everybody. Welcome to DevEd's Weekly Office Hours. How you doing? Hope you're having a good week so far. Hey, Mesh. Hey, Ming. How are you?
Doing well.
Doing good.
Good. I'm going to go make sure that the streams are streaming. And let's see. While I'm doing that, if you guys want to talk amongst yourselves.
What we're doing actually do our introductions.
Yeah, that might be good. Why don't you guys go ahead and introduce yourselves?
Do you want to start, Umesh?
Yeah, so hi everyone. I'm Umesh from Pune, India. I've been building embedded software and hardware from past 10 years for IoT solutions. Thank you.
So I'm Ming. I'm based over in France. I've been a Linux and Unix consultant for over 30 years and within the embedded world for about 15 years now.
And I'm Brandon Lewis. I am a technology journalist who's been in the industry for 13, 14 years, somewhere over 10 years, but under 20 years. And I'm really fortunate to be part of this community and be able to spend at least an hour a week with you guys and talk about the state of the union and as far as embedded and IoT tech is concerned. Oh, there's Zach. What's up, Zach?
Hey everyone, I'm Zach. I've been a software developer for a bit of a decade now, and I'm happy to be here with this panel. Lovely to learn.
Great. All right. Well, anybody else who is in the chat, hello, welcome. Feel free to join the stream if you'd like. You can click participate when you come into the stream. When you come into the platform, there's an opportunity for you to click either just view or participate. And if you'd like to participate and be on screen, you're more than welcome to join us here and talk with us in real time. Otherwise, you can always just put your comments into the chat. So anyway, let's go ahead and get started. Before we dive into today's topic, this week I was at Embedded World North America, which is the first Embedded World in the US. And when I arrived there, it was underwhelming. It started on Tuesday, and I got there and the show floor was a little dead. I think that some of the conference tracks had just begun. So I think people had sort of moseyed out and gone into the conference tracks. And so I was a little worried. But then the next day I came back and the show floor was a lot better. So, I still think that there were under, maybe a max 2,000 maybe people during the couple of days that I was there. But yes, Navdeep, there were a lot of hands-on workshops there. So that's cool. And we had actually an event with IoT Stars right after the first day. So right on Tuesday evening, and a ton of people showed up for that. Like well over 100 people were there. We had panels with PicMig, some TinyML folks were there, networking, food and drinks and stuff. So that was cool. So unfortunately, next year they're moving it to Anaheim. I'm still kind of curious why they would go to Anaheim of all places. I know that they couldn't stay in Austin because the Austin Convention Center is under construction. So we'll see. Hopefully this turns into a good event for everybody. So anyway, that's a quick update on my travels. Let's see. Getting into the agenda for today, same agenda as every week. We already did our welcome and intros. We're going to have a topical discussion, which today is on embedded virtualization. So if you have not worked with virtual systems before, this is going to be a good introduction. I'll give you a brief overview, and then we're going to talk to the guys and all of you in the audience to see if you have used virtualization technology either in development or deployed to a virtualized system and what your successes, your challenges, your struggles have been. After that, we'll go through any asks and gets from the community and then talk about what we're going to be doing next. So as I mentioned, Oops, I didn't update the title here, but if you look down in the description, really virtualization is sort of a trick that you play on your computer, on your embedded system or data center system, depending on where you're working. So the idea here is that essentially you can share the same resources between multiple applications or functions that are running and really get the most out of your system. So this has got a ton of benefits in terms of cost, of course, of resource utilization. You can have multiple applications that are running on the same physical piece of infrastructure. They can share I/O, they can share memory, they can share all sorts of things. So there are tons of reasons to use embedded virtualization. But if you're just getting started, you might need a little bit of a context. So I'm going to jump into the definitions here. And if any of you guys have anything to add or any questions, feel free to just slide right in and add experience or thoughts or anything else. So zooming out, virtualization is something that really started in networking and data center. And it makes sense there because it's a pretty homogeneous environment. You've got a lot of servers that are consist of a lot of the same equipment in terms of processors and operating systems. So the idea here is that you put an abstraction layer between your hardware and the applications that you're running. So as you can see here, like one of the most famous ones is VMware. So, I'm sure if you're familiar with the data center at all, there's a lot of Dell type racks that will be there, Dell and similar. VMware, Dell company, you put a virtual layer in between, and then you've got operating systems and subsequently applications that run on top of it. So as I was mentioning, what ends up happening here is that you can share time. The application will believe, or the operating system will believe, that it owns all of the underlying hardware resources. And because of that, you can maximize, basically what that operating system is able to do. Whereas in other contexts, it may think that it may be limited. So it allows you to get the most out of your application or your operating system within this context. Ming, do you have a different way of explaining virtualization than what I just did?
The main thing for virtualization is actually that key thing of being abstracted, because it isn't just operating systems. I actually started with virtualization on storage, whereby, again, we were abstracting out what the underlying storage was to our servers, and the server believed it had all of the disks, but it was a virtualization of that kind of strategy. So that all this abstraction means that it makes it easier for the end user, because we're going to a known place. What's happening at the back end, the other side of the virtualization, that's somebody else's problem.
For sure. Yeah, and I think that this concept, the abstraction allows for this belief, right, of the application that it has access to more resources all the time that it may actually be sharing, right? But whatever the application is doesn't aware that it is sharing those resources. So it can operate as though it owns everything, when in actuality, you are able to deploy multiple applications. And that's how you get the synergies of like better resource utilization, better costs. And then there are a couple of other really key things, especially in the embedded space, like partitioning, which we'll get to in a little bit. So here is virtualization at sort of the highest level. Sorry, what was that? Were you going to say something, Amesh?
No, I mean, I could simplify this way. Like the first time when I use a computer, for Windows, and I wanted somewhere down the journey, everybody needs a Linux. So what I did is I put my laptop into dual boot. It was very painful. And there were a situation where there were products like VMware or VirtualBox or something, and then you put up, instead of partitioning of drive and everything, you put up like you have a Windows, and then now you can install and run Ubuntu on that. So think like you can run OS or application as many as you want. So you can run a multiple operating system on the top of the hardware. and you can run even multiple applications. Like in the embedded space, let's say if we have a hardware, underlying hardware, on the top of which you can have an operating system. I mean, there are again two types of virtualization, but whatever way you can choose. My point was, on the top of operating system, you can run another operating system, or you can run an software layer like AutoSAR or something like that. So you can run multiple application on the top of it. So yeah.
Yeah, for sure. So actually, Imesh, there are more than a couple of different types of virtualization, and as Ming was pointing out, there are multiple things that you can virtualize. So, for example, here, like you can see, Ming was talking about storage. You can virtualize memory. You can virtualize the network, even, and on top of that, you can also virtualize above the operating system level. I think it's sort of what Imesh was getting to, in the application level. Now, these are different types of virtualization that happen with different technologies and at different levels of the stack. And we're going to get into some of those today. But as you can see, lots of stuff can be virtualized, and this is really effective depending on what your resources are and what you're trying to accomplish. So we won't dive into every single one of these, but as an overview here, you can see here are the different things that could potentially be virtualized. Now, I wanted to start getting into, ways of conceptualizing this from like the data center and server and moving that into more of like an embedded or IoT device context. And this is a pretty good way of thinking about it, right? So in the data center, you can see you've got a rack, right? You take that rack, and we'll get into what a hypervisor is in a second. But you take that rack and you split it up with what's called a hypervisor. You can imagine a hypervisor is essentially like a gate that you put between different resources. So that more or less partitions this one server, physical piece of hardware, into multiple pieces of hardware for all intents and purposes, right? The application believes, like we were saying before, the operating system or the application or whatever it is, believes that it has control over the entire infrastructure, right? So for all intents and purposes, that makes it its own machine. And that's why you hear the term VM, virtual machine, right? It's a machine that is virtualized, but believes that it is its own physical instance. Now, in the embedded space, a good way of thinking about this is like a multi-core processor, for example, right? So if you look on the right-hand side, you can see you've got hardware there. You put a virtualization technology on top of it, or in some cases, it's inside of the hardware. Like Intel, for example, has this virtualization technology that's built into the silicon. And then you can do the same thing on a system on chip. So when you start thinking about like modern embedded multi-core SoCs, a lot of our processors and even controllers today have multiple cores, right? When you start doing things like that, you start ending up with a lot of shared memory, a lot of I/O, and you start getting into a place where you can use virtualization to apply some of the advantages that people in the data center and network have been applying for a long time, but down on more of an embedded target. Ming, you've worked across these different industries. I'd like to get your feedback here on data center.
One of the things that I find amusing are having started out the world in mainframes, where virtualization was all about how mainframes were working. And it's seeing that technology come to the server world, come to the desktop world, and now come down to the embedded world. Of all of these technologies keep on coming down as they're getting more useful and also better understood, and they're maturing, coming down the stack to our level, which is absolutely great.
Sorry about that. Yeah, and I do think that it is interesting that when we look at the way that systems are being architected today, when you look at there's really not a whole lot of new 8-bit microcontrollers that are coming out, right? At the same time as Ming's talking about, technologies are moving down, from data center down. You see a lot of like SoCs and stuff, for example, starting to add capabilities that are moving up. So in the future, we're going to see a lot more what we call MPUs. Yeah, there are microcontrollers. A lot of the microcontrollers that are coming out today don't resemble microcontrollers like of 20 years ago. They look more like what we would have expected to find close to a PC, right, where we've got a whole lot of compute that's happening here. There are a lot of like A53s and A72s that are being put into embedded processors. So at the same time, we're seeing a little bit of a convergence. So this is going to enable things like virtualization to be at your disposal if you're an embedded and IoT device developer. So Umesh mentioned some different types of virtualization. We'll go through a couple of these today, and then maybe in the future talk a little bit more about emulation. But this is a nice sort of way to look at breaking down how you can virtualize things. And this is only one class. So here we're talking mostly about hardware virtualization that enables you to host multiple operating systems. Now, this is this is different from virtualizing an application, which we'll get to right after this. So if you've heard about Docker or similar, that's application virtualization that happens at the operating system level. Here, we're talking about hardware virtualization and running virtualized operating systems. So on the left, you can see the type 1 hypervisor. And if you look across the bottom of these, you can see that on the left, we have hypervisor and then there's system hardware in both other instances. The hypervisor is a shim layer. So there are a couple of different classes of hypervisors, and one of them goes all the way down to the metal, right? It's cutting up basically your hardware resources like that. There's another type of hypervisor, type 2 hypervisor, that's a little bit more abstracted. But for all intents and purposes, the hypervisor is running as the hardware, right? So it's managing the hardware resources. The operating system sits on top of the hypervisor, and the hypervisor is what is doing sort of the orchestration of the resources beneath for the hypervisor. Now, what this enables is that you can now have, if you see like the virtual environment, your operating systems are deployed inside of a box, more or less, right? You deploy an operating system inside of a box. You usually have a host operating system that is, your primary. That's the main one. That's your actual operating system. And then there are guest operating systems that sort of defer to the host that can be deployed in additional VMs. So that's how things look on top of a hypervisor that's providing sort of a shim layer. And then you can also do deploy this into a straight VM. So with no hypervisor. So this is where things like Intel virtualization technology, like I was referring to before, allow you to just basically deploy an operating system into a partitioned, essentially, piece of the silicon, and then you can deploy your host and guest operating systems from there. Ming, do you think that's sufficient explanation of hypervisors and virtual?
It is. What I was also going to say was one of the places I used to use this type of hardware virtualization a lot was in terms of flexibility. Because when you actually buy your kit, you might not know how you're wanting to split it up. To be able to do that dynamically was such a powerful tool to be able to say things like, right, so we're going to start off with it in this particular configuration whereby you've got these resources. And then a couple of months later, you go, actually, what we want to do is reconfigure those resources, give a bit more memory to that bit, take a bit more CPU to that one. And we can then dynamically be able to shift what is happening with our hardware. So the flexibility of a virtualization system from a hardware perspective, it just opened up a whole raft of new ways of looking at utilization.
Mm-hmm. That's a really interesting thing, and hopefully something we'll get to in the discussion, which is, so we keep falling back at this and hinting at it, but besides the fact that you're able to more or less trick, the system into believing that it has more resources than it does, or, the operating system or application believing that it has all the resources, the partitioning and, isolation that happens here. And I mentioned, type 1 hypervisor going all the way down to the metal. This is a type of solution that's a lot of times used in, safety critical type applications where you have to make sure that processes that are running in one instance or virtual machine are not interfering with others that are running in another. Now, that's great. But the other thing, like what Ming is talking about, is it starts giving you the opportunity, especially as an IoT developer, to do a lot of interesting things and streamline your workflow, right? Because now you have to be able to think about a virtual machine as being completely isolated from the rest of the system, even though it's running on the same infrastructure, which means that you can update things within that virtual machine independent of the rest of the system. Which is really, I think, a couple of weeks ago, we were talking to Sanjay had a question similar to this, where we were talking about being able to update safety certified software, right? So if you are now, you're going to have to recertify, depending on the whole entire thing, depending on what the system is. But if you can start isolating your code, your applications, your processes into a single virtual machine, it's a lot easier to attack updating something that's connected than if you're talking about doing, the entirety of a system. And that's a big plus that you can get with virtualization as well. So there's also emulation. Emulation is another type of virtualization. We were talking about this a little bit. This might be a little bit of an offshoot. It's something to handle in another episode. But really quickly, emulation as a virtual tool, what is it?
Well, there were multiple versions of emulation of one things that people might actually be familiar with, Apple Silicon. When Apple transferred from the Intel architecture to the ARM architecture, they were therefore having to cope with binaries that were written for the Intel architecture, but running them on the Apple Silicon. So they had, Rosetta, which was a virtualization layer that was able to translate, and it comes back to that abstraction, translating all of the Intel code onto the actual ARM. So there was a kind of emulation so that your ARM system was emulating an Intel so that the code was able to run.
Yep.
Which, from a Linux perspective, given my background, one of the jobs that Linus Torvalds had when he first moved to America was working for a company called Transmeta, where they were designing a chip that was trying to do hardware-based emulation. And it was a fascinating project, but didn't actually get anywhere.
Emulation has been one of those things that sort of existed on the edge of changing everything for like 20 years. There have been a lot of problems in terms of performance and the availability of what the hardware is you can emulate, but it still is super useful in certain contexts and very very fascinating as a potential tool. Zach, we haven't heard from you. Virtualization. Have you used it? What do you make of it? Are you familiar with any of this stuff?
So I haven't used virtualization in embedded at all. If I'm going, so far my experience has been to use it in like more server type stuff, and we're talking about like situations where you end up running a little box and you're running something like a reverse proxy, and you have a couple of systems living, and this one's doing a website, this one's doing the application, this one's doing the data mining part. That's where I've used virtualization, but I'm quite excited to see how it's used in embedded. And like preparing for this, I ran into a lot of things where like I found out that there's quite a market for virtualization in embedded. There's something called Pike OS, which is a separation kernel. I don't know what that is. It sounds like RTOS systems are still the virtualization systems because it's just separating tasks and applications, but I'm going to learn more. That's my extent so far.
Yeah, no, it's a it's definitely something that I think is worth everybody monitoring very closely moving forward. This is, and we talk about new, and some people say that electronics moves really quickly, and embedded, I don't think we really moved that fast. Multi-core and embedded virtualization is not a like brand spanking new thing. It's been around for many years at this point, but it takes a while for some of these things to get into the market. Nevertheless, you start thinking about, Ming, Zach, me, and a couple of others have been, hovering around this Beagle YAI platform. And you look at, okay, well, there's an R5 core here, right? There are some A53 cores here. What could we do to really make the most out of this thing, running multiple operating systems and stuff? And there are opportunities in there that you may say, okay, well, does it make sense to virtualize something? Especially when you have multiple cores, that just gives you a lot of flexibility. So let's go to the thing that a lot of people may be more familiar with, which is containers. So containerization is, like we were saying, the virtualization of the applications, right? So this is virtualization, up at the operating system plus level. So now if you look here on the left, this is more with the hypervisor here. This is more of virtualizing your operating systems, right? Whereas on the right, you look at the container engine running on top of the operating system and starting to virtualize and partition out applications that way. Have any of you guys worked with Docker or Kubernetes or the like? And what's been your experience? How do you think that this sort of compares to the other virtualization? I'm going to pitch it to you, Ming.
Well, I was going to just give a chance for anyone else to speak because, I've used Docker a lot.
Well, I'm assuming that. Go ahead, Amesh.
So we have one instance to deploy the source code onto IoT device to act as a IoT gateway. So instead of deploying the source code, the scripts, just to run like a bear, we created a Docker image and then we ran, and that's how we deployed into the IoT devices. So that was one instance where we use containerization for IoT deployment.
How about you, Zach?
I'm using containerization in the web quite a lot. Like it's the standard way of doing things. If I want some of my developers, there's two ways of using it. We can use it deployed, which means you're running the software that the client is using or the end user is using. And then you can use it as a developer tool. You have everyone on your team is running on a different machine and you want everyone to be on the same sort of library stack or something or whatever. And that's where tools like Docker become very stable and you can control a development environment very well for that. And then the other end of it is you have production software, which is you have subsystems, or I think they're called microservices these days. You have smaller systems that do singular responsibility, and like a website will have a database system, a backend system, a front-end system, and you'll have a request come in, goes to the front end, it's passed to the backend, and then it's passed to the database, and then it bubbles all the way back up. And all of those could be, and quite likely sometimes are, containers of, I want a Postgres container, I want an Nginx container, I want a Elixir PHP container. That's kind of what I've used it so far for. And quite comfortable with it on that side of things.
I think one of the key things about containerization is the way that this became important was via a sort of massive portability, write once, run anywhere type of philosophy. And of course, this is also out of the data center. So what you would do is a lot of the services, with your application, you would deploy a lot of services inside of a container so that you could push it wherever it needed to go, and you would have everything that you needed to run that application. Now, there's some drawbacks of a container technology like Docker and to some extent Kubernetes, because but that's being sort of addressed through some recent updates. But there's a lot of infrastructure that you need, from embedded perspective, in order to run this, because there's a container management system that you need, beneath the actual containers, et cetera, and this takes up a lot of resource if you're thinking about it from an embedded context. But there are now, more embedded and IoT class, types of containerization, like Balena is one, for example, that you can use that are trimmed down and support, this portable delivery and deployment of, microservices and containerized applications for like edge devices, for example. I think you've used Balena. We've talked about that before, Ming.
I've used a Docker type approach. That is my workflow. I'll be using Docker for, I actually run my Yocto builds within a Docker container, because I'm wanting to ensure that I've got a consistency of host. And by doing it in a Docker container, I know that I've got complete consistency. I put the development kit that comes out of a Yocto build, I can put that into a Docker. I can then distribute that Docker container as an absolute development environment that is the same for everybody that is going to use it. Yep. For a thing like Balena, Balena as their actual IoT system, you wrap up your application in a container and you deploy that container down to your actual IoT device. And so an update is you just restart the container with the latest version. You've now updated your entire environment. And it's quite a very neat packaging system. And then the last place that I use Docker quite a lot is CI/CD. Yeah. Whenever I'm doing a build, then my actual CI/CD server is making use of a Docker container, again, to give me complete reproducibility. And I mean, because I'm working in a regulatory environment, having reproducible builds is essential, so that I know that if I'm using a container, I'm absolutely reproducing that environment totally.
Ramesh, yep.
Yeah, similarly, I think many people who watch here, they know that I use Raspberry Pi for deployment. We spoke last time. And probably the user knows that in past 3-4 years, we've been seeing a lot of version releases coming up. And then this package is broke, that package is broke, you use some libraries. And it was really painful for us to make sure what deploy and what works should be consistent across all the devices that we deploy in the factory. That is where we use this container approach for our IoT deployment. And just not related to these things, but I see it's very much similar, like server aspect is coming into the embedded world, because recently in the world of embedded, we are seeing massive compute power onto the microcontroller even. So when we take some microcontroller, they come with, even if you take a Cortex R series, some microcontroller, you have a supportive Cortex M controller. Sometimes you have a Cortex A as well with it, and very, very high end. It's like a server back in 19th century, where late 19th century, where you have a lot of compute power and people wonder what to do with this compute power. If you do not use it, then you basically waste, because those controllers are very expensive. I think the same way the approach how this virtualization is solving problem here. But yeah, as far as the container deployment goes for the real world use case, if you use open source softwares, a piece of software, then it's very dangerous. You have to use container quite a lot, because you have to make sure, like last time Ming spoke about it, how important it is to note down and bill of material, how to create, to track all these things. And I think that is where it all comes to solve the problem with using containers.
Yeah, it's definitely a huge advantage to containerize things. I think that as we continue to move forward, the benefits, something we come back to very often, is the benefits of the flexibility and the ease of use and deployment with a containerized approach are probably going to make developers less and less embedded developers. I mean, frankly, a lot of the reason that you have containers is so that you don't really have to understand everything about the embedded system. But in an IoT context, it kind of doesn't make sense to do things any other way, especially if you're talking about fleets, right? When you're talking about fleets and you have to deploy lots of updates, and Ming was talking about like version control, right? Like if you have one firmware version and you need to, for example, update it in, one container, you need things like the ability to fall back, for example, to your previous firmware version. Container allows you to do that if there's something that happens like during the OTA update process. There's just a lot of advantages in the context of IoT devices to this type of approach that may outweigh traditional embedded development. What do you think about that statement, you guys? Go ahead.
One disadvantage I've been finding with the containerization approach is it's great for wrapping up your software. But when you want to start talking to your low-level hardware, trying to cross the container boundary. So, for example, I'm trying to do Bluetooth communication. I can't get my Bluetooth adapter into a container to be able to make use of it. So, can't do it.
Yep.
For that, I need hypervisor-based virtualization.
Yes. I mean, and that's a great point. So you look at this slide here, right? And we're looking at two different, I think it's important to note, we're looking at two different types and two different levels of virtualization here, right? And the hypervisor, as Ming's pointing out, we're now beneath, the operating system. This is a key thing to understand, right? When we're talking about containers, we're talking about application at the operating system level and above. And when we're talking about hypervisors, we're talking about underneath the operating system. So you get more access and more control to, the transistor, to the silicon, to the bits and bytes. Umesh, you were going to say something earlier. What was that?
Oh, I forgot maybe.
Okay, sorry. All right. But yeah, I don't want to get into some like pedantic or philosophical debate here, but I do think this is what Ming points out is a very important thing to understand. If you start learning a lot of development in a containerized context, you are not giving yourself complete access to like what we would traditionally consider embedded development. Like I said, this containerized philosophy was built for data centers, right? This was built for Docker and Kubernetes were built for data center environments to allow people to write an application one time and deploy it wherever they needed to. That is not what the embedded market is. That's not what the embedded systems environment is. So just keep that in mind.
Yeah.
All right. So this is actually a way of thinking about it, not so much as on the device, but when you're building devices and building systems. Ming threw over this diagram to me shortly before the session here, and you can see, like, if that's you over here, this is Ming, the purple guy. And he's developing an application and he wants to package it up and deploy it to multiple places, right? So here we have an example of Word, Excel, and you take that and deploy it in a package and then you can distribute it. This is an example of how you could leverage virtualization in your development workflow. Anything you guys want to add here?
Just from it is useful to be able to, from a developer, the more abstraction you can be putting in, it's going to make your life easier. Because if you're not having to think about every detail of that last bit of whatever the hardware is, and you can do a bit of abstraction, you can develop faster, you can develop potentially even more robustly. Because you can go, right, here is the interface that I am programming to, and then, as I say, all the times of abstraction is it becomes somebody else's problem. I work on the concept that There are people far more intelligent than me doing this sort of stuff. Let them do their job.
So I do want to get a recommendation from you guys. If you're an IoT device developer, which it really does, or an IoT developer, which doesn't really mean anything because it's the entire stack, right? If you're going to be involved with developing software for IoT devices, how critical is it that you understand the hardware that you're deploying to, or does that matter at all? Actually, the topic that we had at IoT Stars, the panel that I was hosting, was with a company called Monogoto, who does software-defined networking essentially for IoT. Beagleboard and some guys from ExxonMobil, and the ExxonMobil guys are trying to get rid of all their proprietary PLCs, right? So that they can switch their infrastructure much more easily than they do right now. And the idea here is, okay, well, if we can go into a more standardized, homogeneous approach, we can use more of this like IT data center type development philosophy and sort of use containerized type technology and just deploy and make updates wherever we need to, whenever we need to. Are there significant drawbacks to that? I mean, is this going to be prohibitive at some point, or Ming, like, is it like, okay, well, should have thought of the Bluetooth stack last time, and we'll, time to roll out a new device? Like, what's the future look like, and how would you approach it? How about you, Zach? Like, from your perspective, if you're looking at starting out as an IoT device developer, do you think it's important to learn from the embedded up, or if you were starting today, just like, forget it, I'm just going to start with containers and go from there?
I think it's still not so solid that we can go forget, like, don't understand your hardware. Eventually, at some point, that will be the case, and then it will be a group of, like with the COBOL situation right now. There's a small set of people who understand how this pyramid was built, and they're going to make a living out of maintaining the pyramid. So really, it comes down to like what Ming said. It's not a yes or a no that you have to understand it. We might end up in a world where it's just conventional that you don't understand the hardware, but then it just becomes someone else's problem. But if you are starting today, I would say it's still relevant to understand your hardware and your software through the stack. Maybe not even understand it, but you should at least be aware of, like, what is that component? What does it do? Those two. And then, if push comes to shove and you have to spend 24 hours learning, oh, what does this do? How do I make it work? Then you'll do that. At least be aware of what you're holding and how you're using it. That's what I would say.
Umesh, I mean, this is your business, right? So, if you do you even, I mean, and you were talking about Raspberry Pi, right? Do we just get the most generic, hardware platforms that are essentially, okay, well, we've got our ARM cores, we've got the interfaces we need, and now this just is going to make our, maybe you spend more money on a more general purpose, robust, almost like a PC, right? For your edge device, and so you can create containers and just deploy them to deploy whatever you want, whenever you want, wherever you want.
Actually, when you approach to this kind of situation where the things can be done by just having container approach, like the people can take off-the-shelf hardware and then run some Python script, then probably you would have many things ready. You can able to make things work. Now the question is how stable it is, and are you be able to sell it, and does your client accept that as a solution, or they can just accept that as a prototype which works, but it can still be expect to be improved. So it really depends, like if you have the ability to go and client and convince, then maybe you can get along with it. But as Ming says, in the end, sometimes you really need to dig deeper in it, because there is always one hardware interface. It could be a Zigbee stack, it could be a Bluetooth stack, it could be any stack, and that off the shelf libraries or something couldn't able to help you to make things stable or make things works. And that's where you need a real embedded people. So you can always have, I mean, I have seen most often when you develop a solution, you have a people who are highly enthusiastic coming from the IT infrastructure end. They initiate, they push things, the prototype is very fast. Now the embedded people, they come in and then they make things stable. That is how I have seen. So in the end, you have to go to embedded and go to deeper level. Maybe that's a journey, because you can buy time with it. At least you have something working. I mean, if you go like prototype path, okay. So I think both approaches are fine, but you have to go to embedded. I feel this way, no matter. And then I also I want to add one thing. Through what I have understood as of now in the field, the virtualization could find its place very nicely in the IoT space towards the edge devices, edge intelligence devices. And the other area where hypervisor and virtualization in a microcontroller world works very well is the automotive industry. The reason is because uh, in the edge intelligent devices, the infrastructure looks pretty much like an IT infrastructure. You have a CPU core, you have a huge memory, right? I mean, I'm saying huge memory means 4 GB, 10 GB, right? You can buy some expensive SBCs, and then I mean, it's subjective how somebody can take that, but you have a good amount of memory and you can treat that edge device SBCs as a server, a little on-premise server, right? So it's pretty close to that way. And in the automotive, I realized this hypervisor, I mean, virtualization through hypervisor is very effective because it's very regulated industry. So it's not just you get something, a piece of software working by virtualizing it, but you can really standardize it, get the licensed it, you can save the money on its certifications. So there are a lot of I mean, what I realize right now is the potential in certain area is very high. And in IoT space, the edge intelligent devices is the one to go for.
Ming, I have a question for you related to understanding what you're deploying to. So in a containerized context, right? I mean, necessarily, I mean, it's possible that you may not even know where your deployment or your package is going. So like, what are the requirements, and like, how do you think about developing in this type of environment, right? If you're not necessarily sure, or do you have to be sure beforehand?
If you're developing for a container, the whole point is you're not allowed to be sure where it's going to end up. That's the whole point of it. It's got to be to that generic container. And then what's happening outside that container, that's none of your business. That's something else entirely.
Right. And so what this does, though, is although it's generic, like you were talking about with Bluetooth, you're assuming some things, right?
This is where you get into the things of, you're now saying, right, I actually need to tag this so that it is only deployed on a bit of hardware that has Bluetooth. I need to deploy this, so you now need to know more about, and you're losing a little bit of the flexibility, but then that's part of what you're going to be dealing with. That's how we've always done it. It's how we did it back in the server world. We could say, I need this particular container to be run with a high-powered GPU. I need this one to have an X25 network. So you're tagging, and then you just apply the right container package to the right hardware. Well,
go ahead.
Well, I was going to say, as a complete aside, one of the things when you're talking about generalization versus specific on hardware, this is where you can see the grey in my beard of having been around when I was starting. You had specific machines. We used to have a Lisp machine. So this was a computer that was hardwired to run the Lisp language. You had an APL machine, a computer that was hardwired to run APL. And then over the years, instead of having all of these highly specific task-dependent systems, you got into the general purpose computing. So just from a historical perspective, we could well see, because this is how it's happened in the past, it is highly likely that we will go to more generic hardware for general purpose IoT, which we will then have our IoT developers developing on.
Yep. I mean, that makes sense. The thing that I started sort of chuckling about was when you were saying, we have to tag based on, only deploy to, endpoints that have X resources or characteristics or features or whatever. In your experience, does this mean that you actually have multiple containers based on what is just counterintuitive, right?
Yeah. And then you start losing some of that original flexibility of, well, I don't care where it is or what it is I developed once. You're now developing multiple times, which comes back to, well, that's what I was doing with hardware anyway.
Right, exactly. Okay, well, very good. I was going to open this up for a discussion, and I still want to do that, but wrapping up, here are the benefits, or some of them. This isn't all, this is an exhaustive list, but the key benefits here. So with virtualization technology, you can reduce costs. So obviously, if you haven't picked this up by this time, really one piece of hardware infrastructure can essentially serve multiple virtual machines, right? So you have one platform, but it's operating as though it is, 2, 3, 4 plus systems, depending on how much infrastructure you have. And that, of course, translates into reduced cost. You don't need to have all that hardware infrastructure there. Then, of course, in tandem with that is the improved resource utilization, right? So one of the things, especially in data center, but now increasingly, always in embedded as well, you look at, all right, how much time is my CPU running? How much time is it actually doing something, right? Because this is obvious in data center. If your CPU is not doing something, that's lost revenue, right? So similar sort of concept in certain embedded applications. If your CPU is sitting there idle, and the rest of the resources for that matter, it could be doing something else. Virtualization allows for you to maximize the time that potentially, some of your resources are doing something. So better to have to be active than to just be sitting by idle. As we touched on there at the end a little bit, especially in the containerization context, this can help streamline your development and also maintenance, right? So if you're developing within inside of a container, obviously, depending on how your deployment methodology is, you can develop once and hopefully deploy to the majority of targets. But then we didn't get as much into this, but we did touch on this ability to send targeted updates, right? So if there is something that happens, there's a bug, for example, with inside either a container or inside of a VM, right? You can deploy, an update to that that is sort of separate from the rest of your system without having to, completely reflash the image for the entire system. You can just target either that VM or that containerized instance. And then finally, this idea of better safety and security. And I think something that we've been talking about recently is, if you've got compliance things that you have to address. Ming had a session on SBOMs and, some of the security vulnerabilities and how to approach that. These are things that are easier to look at if you say, all right, well, I've got a partitioned system here. It's sort of reduced. The dependencies are less because it's partitioned. If there is something that happens that needs to be addressed similar to the above, you can look at it in a much narrower scope. So here are just a few of the benefits that you can get out of virtualization. Ming brought up a couple of the drawbacks potentially. There are some other things, it's not free from a development perspective to implement virtualization. Things can get pretty wonky when you get down into the hypervisor realm. You are talking about essentially partitioning a lot of memory, and that can become very complicated very quickly. So there are open source hypervisors out there, for example, that you can take advantage of. There are also commercial ones, of course. Once you get involved, you just have to remember sometimes the free stuff can be the most expensive, and the expensive stuff is just expensive. Anything that anybody either on the stream or in the audience wants to ask or share about their experience with virtualization technology, I'd really like to hear from the folks in the audience. Have any of you guys worked with virtualization? Are you exploring it, deployed it, maybe just messed around with it in your development journey so far? And meanwhile, any of you guys on the screen, any stories you'd like to impart or warnings you'd like to share?
Well, I'll just say for the people out on the stream of when you're asking, are they using virtualization? Are you using AWS?
Yeah.
If you're using AWS, you're using virtualization. That is a hypervisor. That is all your hardware machines. They are virtual. That you're probably using virtualization without even knowing it in so many instances.
Yeah, that's actually one of the key things when we came up with this topic, is that in a lot of instances, even in the embedded context, I mean, now things are becoming so abstracted, right? That in a lot of cases, developers are writing software and they may not even understand that where that's going to be deployed, or what's hosting their software even is actually virtualized already. So this is an interesting topic. If you guys have any questions about this or want to discuss more, please put them into the Discord server, which is there. I just put it into the chat, so we'll have discussions on this, and then all the experts are going to be there available to assist. And other than that, I think we've kind of run through the agenda for today. Next week, any suggestions on what we can do to get 1% better?
Containerize it.
Yeah, containerize it. For you guys in the audience, I'd love to see a couple of you guys come on stage and participate with us. It's a lot easier in the community if we're all part of it. So I'd love to see some of you guys join up next week. When you get to the splash page for the event, there's an option to jump in and join the stage. So feel free to do that. We won't bite. I think that could be our 1% goal for next week. If you have anything for the community, any asks or gets or anything you want to offer to anybody, feel free to drop it in the chat or in the server. And thanks for everybody bringing their grain of sand. Appreciate it.
Amazing.
All right. Heads up. So on Sunday, we are going to have an engineering hour. That's going to be on FreeRTOS, mutexes, and semaphores. So that's at 1500. So the same time as this session started, just on Sunday, the 13th. So you want to check that out. There will be information on that in the server, which is linked to on the screen. And there's going to be a reheat of one of Amesh's sessions, I believe. There's going to be a reheat tomorrow at Saturday morning. I'll drop in information about what's going to be playing. So that's a recorded version of a recent session. So keep an eye out for information about the upcoming activities. And Amesh, did you have something you wanted to add?
No, nothing.
Okay, very good. All right, guys. Well, appreciate your time, and I hope you guys have a great week.
Thank you. Bye-bye.
Thank you.
Bye.
Bye.
See you.
Have a nice week.
Bye.